heat pump diagram on the board so you can understand it. Again, this is going to be my compressor, and this is the component that makes an equipment a heat pump called a reversing valve. I got it in here. This is a four-way valve. One thing I want you to be very familiar with the reversing valve, it has four pipes in it. One, two, three, four pipes. The pipe that is on one side by itself is always going to be a discharge. Make no mistake about it. That's your discharge line. The pipe in the middle, again, is always going to be a suction, which is going to be that discharge is here, and this is your suction. So if you can marry this image into your mind, this begins to make sense. So now, that's what I have done here. I got my four-way valve or reversing valve here. I've taken my discharge from the compressor into this pipe, and also I'm returning into the compressor by the suction, this section, the middle pipe. So what this diagram is missing now is two. It's missing like three more components from basic refrigeration. It's missing something like this, and metering device. If you notice, I'm using the word this and this because when we come to heat pump, we no longer use these terminologies as applies to heat pump. Okay? So in the heat pump, those two components will change names. Again, that is something you must always realize and put that in your head for the rest of your life. So if I want to add those two components and the metering device, I'm going to have something that looks like our regular condenser coil this way. Okay, that's my condenser coil, regular refrigeration. And also, I'm going to have something that looks like again, a regular. I'm going to make it bigger so you can see that very well. So this is our evaporator. So what else is missing on this diagram? We have a compressor, condenser, metering device. But because this is heat pump, this is your compressor, this is going to become what is known as outdoor coil from now on, because we are in a heat pump system. This becomes an outdoor coil. And this one here, which is the evaporator, the refrigeration, gets in the heat pump, this becomes indoor coil. Okay? Make no mistake about it. So all I got to do now is to finish my piping to the four-way valve. Okay? So I'm going to use the black pipe to finish it, black line to finish it up. That's what it looks like. One end of the reversing valve goes direct to the indoor coil, while the other one on the outside goes direct to the outdoor coil. Okay? So I'm going to have this coming out here. So now we have connected all the four pipes in the reversing valve into our refrigeration system. The next component that is missing is going to be our metering device. Very good. This is a basic heat pump diagram. It has all the components that makes a system a heat pump. This is going to be the compressor. Compressor is going to still be the same function that it has in the refrigeration. The function, remember here in the refrigeration, a compressor takes in low pressure, low temperature, superheated gas from evaporator into the compressor. The same thing the compressor will be doing here. It's going to take in low pressure, low temperature, superheated gas from this refrigeration system, from the suction line. That is what it will always take in, from the suction line. That basic function never changes. The discharge on the refrigeration side is always going to discharge high pressure, high temperature, very, very hot gas. Some people call it superheated gas, superheated vapor, but I prefer the term very hot gas. That will be the state of refrigerant in the discharge. It doesn't change in the heat pump. Again, that's what I'm going to have here, going in here. Depends on what we are trying to achieve. The change in direction takes place here in the reversing valve, okay? If I want this equipment to be in the cooling, remember, a heat pump does cooling, heating, and defrost. So if I want this equipment to give us cooling, it's going to be the same as a basic refrigeration, because the discharge is going to go through the outdoor coil to reject heat. And it's going to go in here to reject heat. It's going to go through the trim device, come through the indoor coil to provide the cooling. It's going to get back here into the suction, and as long as we're in the cooling mode, it's going to be your basic refrigeration. If I want this equipment, heat pump, to go into a heating mode, whereby this time is winter, we want to keep the space warm, the refrigeration system is going to be the same thing here in the discharge, super, very high pressure, temperature, super, very hot gas. That's what's going to come here. But this is where the change in direction is going to take place, in the four-way valve, okay? Some people call it four-way valve, others call it reversing valve. It doesn't matter. Whatever the solenoid pushes and opens. So if we are going to be in the heating mode, the slide is going to push here to direct this movement right here, right into the indoor coil, where we will be rejecting the heat in the indoor space in the winter time to keep this place warm. Then it goes back again and returns back into the system. So far, we can achieve cooling and heating, but with heat pump comes with so many other unforeseen problems, like defrost in the equipment. If the outside temperature is in the 50 degrees or 60 degrees, and you are trying to dump in the same outside air, cold air that is coming from this equipment, you find out that at the same time it will create a problem, it will provide another challenge that was not foreseen, which is the frosting on the equipment. You will have this equipment start to form ice because we are heating. It starts to form ice here, which means it's restricting the airflow to the outside. In order to deal with that, there are so many sensors, temperature sensors, that comes with a heat pump to help to solve that problem of icing on the outdoor coil. So if this equipment is iced up and you want to de-ice it, all you have to do is to switch it in a defrost mode. And the defrost mode is nothing other than cooling. We're going to put the equipment into a cooling mode without the outdoor fan working. So if we go into cooling mode, we're going to turn this fan off so that all the warm or hot temperature in the discharge will go over here and defrost the ice. This process doesn't take long, it does less than 3 or 4 minutes, less than 3 minutes to defrost the ice. And once this sensor here sends the signal to the PC board that ice is completely defrosted, the equipment will automatically go into heating again. So that's a basic heat pump operation. It's very simple, but if you don't have enough knowledge of how this works, it's going to be a challenge on the job. So with this type of situation, There are so many safeties and so many other sensors that come along with a heat pump to help the equipment perform very well.